Okay, welcome everyone. My name is John Morrow, and I'm a professor of materials science and engineering and also chair of our graduate program at Penn State. First thing to note about our program is that it is an inter-college graduate degree program. And what this means is that we're recognizing that materials science is a very interdisciplinary field with professors working in materials research, not just in materials science and engineering, but also in related fields such as physics, chemistry, chemical engineering, and so on. And what you'll see is that one of the nice things about our program here is that you would have the opportunity to be advised by either a professor who is formally in the Department of Materials Science and Engineering, or one of about 40 other professors who are appointed to our graduate faculty from other departments as well. So there's a really wide range of faculty advisors available, covering a very broad spectrum of materials research. Our agenda for today is that we're going to start with a 10-minute overview of the program by myself. Then I'm going to turn this over to Dr. Stephanie Preston from our Fox Graduate School at Penn State, and she is going to talk about the diversity of our graduate school here. Then we're going to have brief research overviews by different professors here in different areas, covering structural materials, computational materials, soft matter, the Applied Research Laboratory, and so on. We're going to have virtual lab tours of a couple of our buildings. Then there's going to be a presentation from our students about what it's like to work in State College. And then after that, we're going to break out into discussion rooms, and everyone can self-select which rooms that you would like to visit. We'll have separate rooms for organic materials, inorganic materials, computational materials, and student life. Meanwhile, Haley, Sue, and I are going to stay out in the general room to take any general questions that people have, and then we'll wrap things up 2 hours from now at 3 o'clock local time. So why Penn State for materials? Penn State is very consistently ranked as the #1 program in the United States in materials science. This ranking comes from the National Science Foundation in terms of the activity of research that's taking place at different universities. For 4 years in a row now, we've ranked as #1 in materials science and #2 in materials engineering. So in addition to our top-ranked research program, we've got a really large base of students and advisors. We have about 180 current graduate students, the vast majority of whom are PhD students. And we've got about 80 different faculty advisors from both within our department and from other fields that are adjacent to material science and engineering. What you'll see during the tours today, the virtual tours, is that we have unparalleled research facilities, really phenomenal buildings, as well as equipment for doing research in material science. And we also have a very wide selection of courses, both within material science and engineering, as well as adjacent fields where you can take courses as electives. So I'm the chair of our inter-college graduate degree program in material science and engineering. Our co-chair is Dr. Lenahan, who's a professor of engineering science and mechanics. We have two wonderful graduate program coordinators who are here with us today, Sue Hyde and Haley. All three of us will be here in the main room to answer any general questions that you may have. Now, for our PhD program in material science and engineering, we have 3 core classes that everyone has to take. Those are thermodynamics of materials, kinetics of materials, and principles of crystal chemistry. And the cool thing here is that you're learning these courses not just from anyone, but from people who've actually written the textbooks on these topics for all 3 of them. And we also have a 1 credit hour colloquium that students have to take each semester where we bring in external speakers. And there is a 1 credit hour professional development class that is required your first semester. Beyond that, we just require 9 credits worth of electives. These are our courses that you can choose from, working together with your advisor to see what would be the most helpful for your own research. And beyond the course requirements, there are 3 benchmark exams, which are standard for PhDs here in the US. A qualifying exam, within the first 12 to 18 months, a comprehensive exam about a year after that, and then the final dissertation at the end of your PhD. We also offer a lot of opportunities for professional development. The Materials Research Society was actually started here at Penn State, and we continue to have a very active chapter led by our graduate students. And they have a lot of opportunities for social engagement, professional development, and so on. We also offer an annual Materials Day, which is organized by our Materials Research Institute, and a lot of great opportunities for connecting with people in the industry as well. A note about our graduate admissions process. In our program here, we admit students not into the general program, but directly into specific research groups. So it's really important to make those connections with faculty members of interest, because if you are accepted into our program, you are accepted into a specific advisors group. And this ensures that you're going to have a good fit between what it is that you're wanting to study and who you get to work with. And it also enables you to hit the ground running with your research. Now, assistantships, all of our PhD and thesis-based master's students are covered by assistantships. These cover both a stipend and tuition remission. It includes a very good healthcare plan too, that where Penn State covers 80% of the cost of the premium of that plan for health, dental, and vision. And when you're considering different opportunities for graduate school, please be sure to look at to compare benefits as well, and also to check on the cost of living, because the cost of living is quite a bit more affordable in a place like State College compared to many other places. Now, I mentioned our amazing buildings. One of them is the Millennium Science Complex. Dr. David Fecco is with us today, and he's going to give us a virtual tour of this building. This is an amazing facility, and we have faculty of over 200 faculty who work together at the facilities here in the Millennium Science Complex. It includes quiet labs shielded from vibration and electromagnetism, very impressive characterization facilities, as well as synthesis facilities. The Millennium Science Complex includes our nanofab laboratories and our materials characterization laboratory, which has about 30 professionals who are there to help work with you to use the characterization facilities. The home of our department is actually in Steidle Building. If you look at the front of Steidle Building, you'll see this facade from 1929, but it's been completely renovated on the inside. If you look at the back of the building, you can see the modern glass facade there. And so we've got 4 floors of very impressive laboratories, our department offices, computer lab, conference room, student conference areas. We also have our undergraduate teaching laboratory here, advanced processing laboratories, 3D printing, glass lab, computational lab, thermal properties lab, and Ryan is actually going to be giving us a tour of the Steidle building virtually a bit later. So with that, I'm going to stop sharing, and I will take questions later in the program. I'm going to turn this over now to Dr. Stephanie Preston.
Good afternoon, everyone. My name is Stephanie Danette Preston. I am the Associate Dean for Graduate Educational Equity and Chief Diversity Officer for Graduate Education here at Penn State. I'm here to give you a brief overview of the Office of Graduate Educational Equity Programs and the services we provide. The office was established in, did that move? No, it did not. The office was established in 1987. And we were established to foster community amongst diverse students here at Penn State. And so currently we serve a large group of students, from international students, also African-American students, our indigenous populations, as well as our Latinx students here at the institution. The office has broadened to include some international students in particular, because they feel isolated on this campus. And so if there are opportunities for you to engage, or if there are things that you would like to talk about, feel free to reach out. The office is also the home to the Ronald E. McNair Scholars Program. If you know anything about the Department of Education's TRIO-funded programs, this office houses the McNair Scholars Programs. The other programs are housed in the Office of the Vice Provost for Educational Equity, and that's in Old Main, not to be confused with the Office of Graduate Educational Equity Programs. And so we're two separate offices, different scopes altogether, but this office primarily works with graduate students here on campus. Okay. In a nutshell, what we do is we work to recruit students, our undergraduate underrepresented students from domestic programs across the institution, but our service does not just extend to that group. We collaborate with our academic colleges and units on fostering a culture and climate for students to thrive and survive here at the institution. We develop professional development programs. So we have an in-house professional development associate director whose job is to work on career and professional development. That's career in academia as well as career outside of the academy. We also we provide student travel awards, and those awards are small. We like to see them coupled with our partners in other colleges to ensure that we are using resources across the board. External funding, we are the home of the Ronald E. McNair Scholars Program, which is external to Penn State, as well as the Sloan Scholars Program, which will be sunsetting in a year or two. And so the Sloan Scholars Program provides top-up scholarships to students who qualify in those particular areas. We support our cultural our cultural graduate student associations across the campus and provide them with a home away from home. And if they need help, they're allowed to tap into us to offer sort of guidance as well as to help them foster community. We do support those organizations financially in some efforts that they do. In addition to the Graduate and Professional Student Association, which also has some sort of supporting, which receives some support from this office, as well as the Office of Graduate Student Affairs. And we offer a safe space for underrepresented graduate and undergraduate students here. Now, again, I've mentioned that has broadened its scope, one, because students have felt the need that they needed community also on this campus. And so things are not limited just the undergraduate or graduate students or our underrepresented students. So we've been supporting a number of different students in a number of different areas for a long time. One of the other things I'd like to highlight that the office does is we provide, we have an in-house associate director for wellness and mental health and well-being. And so that person's job is to foster a community where students can thrive as well, but they also meet to triage sort of the common case scenarios that students may be running into with time management, budgeting, issues or challenges with advisors, or even staying focused in courses and things like that. So there are a number of different people and different avenues in this particular area that we use to support the student and create a well-rounded environment. One of the things that I want to highlight is if you have not, or if you're not in the application stage at this point, we do house the Graduate Schools Open House. This past year, our open house was the 17th through the 20th. With that, the next iteration of dates, we are waiting for the football schedule for next year. Of course, you can't plan too soon in advance, but that's an opportunity where we invite students to campus to meet, network, speed network with our graduate faculty, staff, and students. We bring the students here, we fly them here. We provide the shelter, the lodging, as well as the food. It's an opportunity for students to engage with our faculty, staff, and students, as well as alumni, because we bring alumni back to do some of the shop talks that we have. Some of the other programs, if you are not at the application stage, is the Summer Research Opportunities Program. This program spans across the Big Ten Academic Alliance. So you'll see a number of the other Big Ten schools. There are 18 in total. I believe 17 participate, who hold research experiences for students during the summer. Our program is 8 weeks in total, and we offer stipends ranging from $3,000 to $5,000, depending on your discipline. In addition to that, the opportunity comes with housing, room and board. All of those things are included as well, in addition to the stipend that is received by the students. Some of the other events and whatnot that I'd like to highlight for us is the Our shop talks are our intelligence community talks. So again, we talked about the career and professional development aspect of this particular opportunity, or the opportunities within this office. And with career and professional development, we hosted more recently a talk with the intelligence communities. A number of people may not necessarily be as attuned or know what the intelligence communities are looking for, but they're looking for English majors, English minors. They're not looking just for STEM folks. And so this is an opportunity for them to engage with our colleagues and alums that are in the Department of Defense, the Department of Justice, those particular programs, et cetera. We also held empowerment coaching. We know that imposter syndrome is real, and our students suffer from that, thinking that they are not good enough to be in certain spaces. And we want to make sure that students feel like they are good enough to be here. If you're here, you're supposed to be here. And so we hold workshops for that as well. Among other things that we've hosted our meditation Mondays, where you're able to come, relax, get your week started off at a slower pace, but making sure that you are aware that these opportunities, or that there is a resource here in case you just need some time to woosah, if you will. And in the beginning of the semester, we have a Connections Forum, or a Welcome Back Forum, which introduces our students to the resources that the institution has for graduate students in particular. And that includes from finance to the counseling and psychological services to different affinity groups and a number of other things that are offered here on campus for graduate students. And last but not least, some of the programs that we had, well, actually I have one more slide on this. And last but not least, in some of the efforts around cultural connections and mixers, you see that again. We also hosted a DC bus trip in February to the African American Museum of Natural History and Culture. And we had a nonprofit alumni careers panel where those individuals who are interested in pursuing nonprofit, they were able to work with or talk with or engage with our alumni to discuss sort of opportunities that we possibly have there. And the last slide with regards to opportunities to engage, or at least what the office does, we had a first generation graduate student symposium that's held in the spring. We know National First Gen Day is November the 8th, but this was an opportunity for first gen students, first and family graduate students to engage and talk with the community, foster community, talk with the community about their experiences here. And we were able to provide resources for them. Another program around social justice and advocacy is our I Stand With Immigrants program. That has been run out of this office now for 2 years by one of our graduate assistants. This is a project that's near and dear to her heart as well as to mine. And so making sure that we know that our students know that we are here to support them. You see that in our programming as well. And last but not least, we always have some sort of celebratory event. If you don't know OGEEP as a programming unit, you will with this. So this is one of our large scale events that's held at the end of the year to celebrate the accomplishments of our graduate students. This is for those who are graduating with their master's degree, who've passed their comps, their qualifying exams. Some of these things may sound unfamiliar to you, but if you are familiar with them, if you're not familiar with them, it's just a time for us to celebrate our graduate students and to wish them well for the summer, even though they don't go too far for the summer. My last slide is nothing more than our contact information. So if there are things that you need to reach out to me about, feel free to contact. I would definitely say contact Tammy Dudick because you all are students or potential students. So Tammy Dudick would be the person to reach out to. There's a main email address, which is ogee@psu.edu, or TLD, and I believe it's 31. And since we're showing pictures of buildings, this is our building, the Kern Graduate School. This is the home of the graduate school. I always tell people jokingly, we are in Kern. My office is in Kern, across from the university's largest Panera. That is all I have. I welcome questions if there is time.
So I'm Allison Beasley. I'm a professor of material science and engineering, and I'm one of the faculty working in the broad area of structural materials. So I'm going to kind of talk a little bit about the types of research we do in this area, and I'll show some of those faculty. And please feel free to reach out to any of them if you're interested in their particular areas or ask questions. So a lot of us are working in this area and that I can generally say is materials for extreme environments or energy. So this is where we're thinking about new materials to kind of push the boundary conditions on temperatures and pressures and corrosive environments and nuclear applications to try to say, okay, let's Let's look for ways for, more efficient systems, and as well as clean energy solutions. So we're working on the materials there, and I'll talk on the next slide about how we're addressing experimental and computational directions. So that's one area. Another area where many of us are working is in advanced manufacturing. So thinking about new and emerging manufacturing methods that reduce, hopefully, the energy and waste. So here we have people working in the areas generally of processing science, additive manufacturing, cold sintering, other methods. The idea here is to say, let's think about the different processes that we have to fabricate materials in different, in this case, alloys, and how we can modify those and design new materials. And then broadly, many of us are working in the area of sustainability. So thinking about things like metal separation or recycling and reuse and lightweighting. All of these things are trying to, again, push towards this idea of how can we be more mindful and efficient with the use of our resources. And so trying so I drew these kind of as sort of a Venn diagram to show that there's lots and lots of overlap between these different areas. And these aren't the only things that we're working on, but these are three kind of general thrusts that we're working in here at Penn State in the area of structural materials. And I also, for this next slide, wanted to kind of point out that when we think about our processing structure property relationships for structural materials, we're very heavy in merging experimental methods and as with computational methods. So in terms of processing, we're doing a lot in the ways of advanced manufacturing methods, such as what I listed: additive manufacturing, cold sintering, spark plasma sintering, or field-assisted sintering technology, as well as traditional manufacturing methods and welding. And then on the computational side, we have folks working in the modeling of that. So things like thermomechanical modeling and fluid flow and the modeling of these various processes in terms of the residual stresses or phases that develop. When we think about structures, we do a lot of characterization to see, what the material is that we've fabricated, what are things like phases, texture, defects. People are working in all of these different areas. And then to complement that, there's computational modeling in those areas as well. So I have listed here thermodynamic modeling and phase field modeling to understand how structures of materials evolve during processing. And then finally, in the area of properties, we have work in measuring properties such as mechanical, thermal, magnetic properties that these materials would be required of these materials and service in the various applications that we just talked about. And then we have, to complement that, multi-scale modeling. So we have folks working in molecular dynamics, things like dislocation dynamics, crystal plasticity, continuum mechanics. So all of these fields are covered. And so this is sort of a list of some of the faculty working in the area of structural materials here at Penn State within the material science IGDP. And so we have Tara Sankar-De Broy, who does a lot of work in the numerical modeling of fluid flow and heat transfer. So for example, in welding and additive manufacturing, this is the sort of the studies that his group does. We have Professor Ho-Jung Kim, who works in the area of electrochemical processes, metal separation, recycling, and corrosion. So a lot of experimental work in that group. Arthur Mata has done a lot of work in the area of materials for nuclear power, so trying to understand how those materials degrade and can be improved. Professor Darren Pagan works in advanced manufacturing and then in situ and 3D characterization of materials and structural materials specifically, as well as micro scale modeling and data analytics. Professor Todd Palmer works in the area generally of additive manufacturing and welding, so a lot of sort of experimental work and the effect of various alloying on materials. Doug Wolf works in the area, many areas. Some of them are listed here, so multi-layer coatings and functionally graded coatings, so a lot of work in thermal barrier coatings. So for being able to push to high temperature applications, so ceramics and refractory metals and nanocomposites as well. And then in my group, we work on multi-scale experimental and computational mechanics. So we have a heavy focus on additive and advanced manufacturing, but we do also work in more traditional metals and trying to link what we see at various length scales to the resultant deformation and failure behavior of materials. So linking experimental characterization and computational modeling. And then finally, I also point out here that we have the DARPA manufacturing demonstration facility for metals and additive manufacturing here at Penn State, which is our Sim3D. So this is a metal additive manufacturing facility that we have that allows us to really probe and push forward the directions of advancing additive manufacturing in terms of new alloys, new processing, and new understanding of process structure property relationships. So I put these up here. If you have, many of us will be around later as well, but if you have questions, please do feel free to reach out to any of us.
Great. Thank you so much, Dr. Vesey. Dr. Reinhardt, I think you're up.
So this is actually a great segue because, as Dr. Vesey mentioned, a lot of the stuff going on in the structural materials area has a big computational component to it. And so I have here just kind of a overview highlight of some of the different computational methods that are being used at Penn State in our material science program. And I think the thing that I want to emphasize with this slide is just that we have really like world-class experts at all of these different areas for different kinds of materials and studying materials at different length scales and different physical phenomena in materials. And so from like quantum mechanics with density functional theory up to empirical force fields, especially like ReaxFF, the inventor of that is here, but we have other experts in the area. And then going up in sort of length scales to phase field and CalFad methods, and then to, as Dr. Vesey was mentioning, some kind of like CFD and finite element type methods, as well as a lot of other kinds of methods that are not, part of these simplified kind of categories, right? So like statistical mechanical methods and specialized methods for different things. I'm thinking of Dr. Morrow, with like glasses, for instance. But really like world-class experts in all of these areas, as well as resources to utilize them. So I don't have any like pictures or anything, but we do have a big computational cluster that we have here at Penn State. So we have sort of resources to deploy these. And another thing I didn't put on this slide, I didn't know exactly how to do that, but in addition to these sort of traditional computational material science approaches, many of us are using machine learning and artificial intelligence approaches kind of in conjunction to do materials design. So for me in particular, my specialty is materials informatics, using ML and AI approaches to support and augment our traditional computational program. So for instance, I teach like an applied machine learning course at the graduate level. But I can say that, many of my colleagues that work in the area of computation do utilize very modern sort of state-of-the-art ML methods, to build on our expertise in these traditional approaches. So let's see. I just went through our directory online and grabbed some of the core computational faculty in MatSE and listed a little bit of, the techniques they use. And so you'll see here, Dr. Vesey's there doing, mechanics and thermomechanical type stuff. Dr. Liu is, a world-renowned expert in CalFad and DFT. Dr. Chen is a renowned phase field expert. Dr. Morrow is, renowned for work with glasses by a variety of methods. And then the other thing that I want to point out, in addition to sort of our high profile people that use a lot of methods, I put this little asterisk for people that I know do a significant amount of experimental work in addition to their computational work. And I think this is really special. People that can do both really state-of-the-art theory and computation, and then also do work in the lab. And there's a lot of that going on in this department. So if you're interested in sort of having a flavor of both of that, you can definitely find it here. And even for students in my group, that don't do any experiments, we work with people like Dr. Beasy to work directly with experimental data as well. So these are our MatSE faculty, but as Dr. Morrow mentioned, MatSE is technically a program. It's beyond just our department. And so I also grabbed these people off of our IGDP faculty list who do computation, including especially like Dr. Fichthorn and Dr. Crespi, who are, pretty famous experts in their areas in CBE physics. You'll see like electrical engineering here, nuclear engineering, chemistry, and mineral engineering. We have not just the people that are housed directly in MatSE, but also this IGDP gives you access to advisors maybe in tangential areas that also work on materials. Right, so that's it for me.
Great, thank you, Dr. Reinhardt. Dr. Sinha, you're next.
All right, so hi everyone, I'm Naridi Sinha and I'm an assistant professor in this department, and I'm going to give you an overview of the polymers and the soft matter research that's done in the material science and engineering department. So I just want to highlight that the polymer and the related fields to polymers is projected to grow in market size to double its size in about 10 years. And this has brought up this conundrum that we have to also look at ways to make these polymers sustainable, as well as promote a circular economy. And those are some of the questions that we think about a lot in this department, especially in the polymers and the soft materials community, as you will see in amongst our faculty. So the usual research areas are in composites and blends. So these are polymers that are combined with other types of materials, which results in a lot of overlap with other faculty research focus groups, as well as colloidal particles, which are very important for paints and for making small devices and nanotechnology, as well as biomaterials and biomimetic materials. So I will just highlight some of the faculty that work in various regions in this sort of puzzle here. Again, emphasizing that moving forward, a lot of the questions that we seek to tackle are related to circular economy and sustainable polymer research. So first of all, let's discuss some professors who work in conductive polymers. Professor Nuti Fafa Dumon, who is a new assistant professor. He works in photovoltaic and optoelectronic polymeric material applications. We also have Professor Enrique Gomez, who works on electronic polymers and organic solar cells. So you can reach out to them if you're interested in these kinds of applications of polymers. Then there is a diverse group of faculty who are working on questions related to polymer nanocomposites. I have just highlighted the ones who will probably be taking students. We have Professor Rob Hickey, who's working on questions related to pre-ceramic polymers and polymers in extreme environments. His group works on colloidal nanoparticles and composites, as well as biologically relevant polymers as well for biomedical applications. So this is a very diverse research group, and you should totally reach out to him if you're interested in these questions. Professor Ching Wang is an expert and a leader in ferroelectric polymers, and his group also works on device fabrications in these applications. Then we have Professor Clive Randall, who is a distinguished professor at Penn State, and his group works on electroceramic materials, where polymers are sort of the other types of materials that are combined with the ceramic materials. So this is where there is a lot of overlap between the different concentration areas in our department, and our department is also very collaborative. So there are a lot of questions that can be answered at the interdisciplinary scale between different types of materials, as you can see on the slide by the types of questions that the faculty are interested in. Then There are multiple professors who work in the biomaterials and biomimetic polymers field. There is Professor Dipanjan Pan, who is interested in using polymers for constructing smart molecular medical devices. And then Professor Urara Hasegawa, who works on polymers for cancer drug delivery systems and also other kinds of drug delivery systems for different types of diseases. So these are more biologically and biomedically relevant projects if you're interested in those types of questions. And then myself, I work on biomimetic polymers. So we try to learn from natural systems to make synthetic materials that can be used for different types of applications, such as biomedical applications and electronic applications as well. And then finally, we have a bunch of professors who work in the field of polymer physics and theory and design. There's Professor Ralph Colby, who's an absolute leader in the field of polymer physics. His group does a lot of rheology of polymers and melts. So he's an excellent faculty for tackling those kinds of polymer theory related questions. Then there is Professor Carlos Lopez, who is a new assistant professor who joined the department as well. He works on questions related to polyelectrolytes and ionic liquids and uses a lot of rheology as well as small angle scattering to ask more fundamental questions about these types of materials. And then, of course, we heard from Professor Wesley Reinhardt. There's also Professor Susan Sinnott, who work on computational sciences for new soft material discovery. And I finally want to highlight that Penn State is unique because we have two very big institutes that provide support to faculty and grad students for doing research. The two major ones that I want to highlight are the Materials Research Institute that houses multiple characterization techniques that you as a grad student will get to actually use, which is something that is unique to Penn State. So we have suites of all types of characterization techniques that are very, very important for polymer and soft material research, as well as the Huck Institute of Life Sciences, which houses many complementary techniques for soft materials characterization, synthesis, and as well as applications. So how do we translate some of our materials for actual biomedical applications? And so there's a lot of support here. And so this really contributes to excellence in polymer research because of the world-class characterization facilities and research staff. And if you have more questions about how you can get access to these institutes and work with them, I will be in the breakout rooms and you can ask me questions.
Great. Thank you so much, Dr. Sinha. Dr. Crone, you're up next.
Yeah, so I'm Dr. Matthew Crone. I'm part of the Applied Research Lab, and I will just try to give you a brief overview of that organization, and we'll be happy to take any questions. So the Applied Research Lab is the largest interdisciplinary research organization within Penn State. And it is a DoD designated UARC, or University Affiliated Research Center. And what that really means, and I'm not going to go through all the list here, is that we maintain a special long-term strategic relationship with the DoD. And really, we look at ways that we can apply technology and research and development activities to help respond to evolving needs and be able to have quick response to capabilities. We were founded shortly after post-World War II in 1945 and have been supporting the nation for over 75 years. Really, our product is critical research in people, and we look to provide cost-effective innovation to support national security objectives. We represent about $4 million of the overall research annual expenditures at Penn State University, and we operate under a large IDIQ NAVSEA contract that allows us to quickly respond to DoD needs when needed. As I mentioned, we're a very large organization, have about 1,500 employees, including roughly 200 students and 9,000 square feet of state-of-the-art research facilities. And part of our mission is to help contribute to the education, research, and land grant mission of Penn State University. And this is how we engage with the university by, as research faculty, being able to collaborate and work within the academic departments to help to advise various students. We're organized or into our designated competencies, which make up the offices which we represent. I'm part of the materials and manufacturing office, but you can find materials work in all 4 offices. They include communications, information, and navigation, looking at how do we send and receive signals, how do we position ourselves. Materials and manufacturing focuses on some of the things we've already talked about today, such as additive manufacturing. How do we produce the materials, and how do we look at the supply chain and logistics associated with the DoD needs? Fluid dynamics and acoustics is probably one of the oldest office years within ARL, and it is focused on understanding fluid flow and fluid dynamics in undersea situations. And then our undersea systems office is focused on, how do we build various undersea systems. Whoops. So I'm not going to go into all the details here, but I think the purpose of this slide is to kind of show the areas of research that the folks within the Applied Research Lab are interested in. And so as you look at that, I could probably focus a little bit on the materials and manufacturing office. So myself, we look at electronic materials and devices. This is looking at novel ultra-wide bandgap materials for use in high power or RF applications. We have a team outside of Pittsburgh that looks at laser processing and sensors and laser weapons. We also support 3 of the 7 ManTech centers, which look at manufacturing technologies for the Navy and how to reduce costs by implementing new applications and technologies, such as things like cold spray, where you can reduce the time for repair. We spend a lot of time in additive manufacturing of materials. And you can see across the organization, there's lots of faculty members within ARL that are working on various materials problems. We support multiple student programs. One of those, which is probably most relevant to the audience today, is the Eric Walker Assistantships, which are ARL-funded Walker Fellowships. We put about $3.2 million into the Walker Fellowships along with the undergraduate internships. We also support a SOAR outreach program at $1 million, which helps to bring in student opportunities in applied research. It's a 10-week intensive research experience that we run every summer. And then we also have about $2.1 million in student-supported research. So I encourage you, if you're interested to know more about ARL, to look at the website, which is listed at the bottom of the screen here. Happy to also take any questions. Feel free to reach out. Thank you.
Great. Thank you so much, Dr. Crone. All right, Ryan, you're up next.
So my name is Ryan Spangler. I'm a 4th-year graduate student at Penn State under JP Maria. Dr. Maria is currently on a flight from Japan right now, so I'm filling in for him for today. But I'm going to talk about his lab a little bit. Sorry. So our primary collaborators as a group, we work across the university with a bunch of different Penn State professors and groups, as well as across the country with different universities and national labs. To talk more about our lab in specific, we have a fairly sizable lab space we primarily do thin film deposition using PVD, which is physical vapor deposition. So in our lab space, we have 13 different tools for doing that. We have a variety of different characterization techniques that we use to support our synthesis requirements, as well as powder processing. And JP's been building this lab over the period of over 20 years. So there's a good deal of experience that can be passed down to everyone else. So as you may have been able to tell, this is a picture of our lab. Each of these scary looking things is a PVD system, mostly sputtering. So the first batch of samples I'm going to look at here are equipment that we use to grow novel ferroelectric materials. So a couple years ago, JP's group found that if you mix certain materials, for example, zinc oxide and magnesium oxide, neither of which are ferroelectric by themselves. But if you put them together, you can generate new ferroelectric materials. And so now there's this huge thrust towards developing and discovering new ferroelectric materials. So we have a good portion of the lab dedicated to that. We also have a good portion of the lab dedicated to infrared nanophotonics. This started with the CDO project a couple years back, which we have thus expanded to other materials such as indium nitride, and we also use an E-beam evaporator to grow various stacks for similar goals. We are also interested in growing transition metal carbides and borides. These are for ultra hard or ultra high temperature ceramic coatings. We also are starting to work in the field of quantum computing by generating high purity films of calcium oxide and cerium oxide to use as hosts for qubits. And then finally, we have a big portion of our lab is working on high entropy oxides. We have 2 different pulse laser deposition chambers to support those goals. And so at the last count, we had at least 48 different materials that we were able to grow thin films of, and this number is continually increasing. To take a look at the characterization that we have available, most importantly, we have SEM, XRD, ellipsometry, some electrical testing, and these are all useful to make sure that our progress is efficient and we're able to get a feedback loop where we can grow a sample, characterize it with as many techniques as we want, and then grow the next sample, having that knowledge in order to make the next sample better. As part of our group, we also do ceramic processing. So we're fully equipped for everything from powder batching to ball milling, pellet pressing, all the way down to sintering in a variety of different furnaces. And so we use this both as for ceramics as an end goal, especially for high entropy oxides work, as well as to create sources and targets for thin film deposition. From a human resources standpoint, we have 14 full-time graduate students in the group with 1 research fellow and a postdoc on their way. And we also are always happy to accommodate and train junior visiting researchers and also accommodate more senior visitors for mentoring opportunities and things like that. And so just to summarize and put everything back on one screen, these are our primary research activities that we're currently working on. But really the main point is we like to do whatever we find fun and interesting, and there's a lot of space to be creative to come up with new solutions and new ideas that may turn into a major research list. And I believe that's all that I have. So thank you.
Great, thank you.
Welcome to Steidle Building, the home of material science and engineering here at Penn State. My name is John Paul Maria. I'm a faculty member of our department, and I'd like to take this opportunity to give you a tour of our facilities. We're now in the Steidle atrium on the ground floor. This is a large space that is used by graduate and undergraduate students for studying or just relaxing between classes. It is also event space that is used for different research competitions or for different department social events. Steidle Building supports the department administrative activities, the undergraduate laboratories and classrooms, as well as graduate laboratories and office spaces. We're now in room 401 Steidle, also known as the Rotunda. It's a room that's used for lectures, for classes, and very often for student dissertations. This frame highlights the historical transition of Steidle from its original 1929 state to the newly remodeled state that was completed in 2016. Behind me, you'll see a large glass wall behind which are about 21,000 square feet of laboratory space that house a large fraction of our department's graduate research. We're currently in the laboratory space on the second floor of Steidle Building in an area that's occupied by the Maria Group. Our group specializes in thin film preparation, And around me, you will see and hear a number of instruments that are used to make very thin coatings, primarily but not limited to electronic materials.
My name's Ian Mercer. I'm a first-year grad student in the Maria group. This right here is atomic force microscopy, or sometimes called AFM. Right now I'm looking at the surface morphology and roughness of aluminum boron nitride ferroelectric thin films.
Magnetron sputtering is one of the most common methods for preparing thin films. This instrument here is a tool that we developed to sputter calcium oxide. Calcium oxide is an interesting host for qubits, which may enable modern quantum computers.
Hi, my name is Darren Pagan. My research group studies the atomic and microscale origins of the mechanical and functional properties of crystalline materials. We do that through combinations of novel in situ characterization, big data analysis, and computational modeling.
Hi, I'm Lutifafaya Odumo. I'm Professor of Material Science and Engineering at Penn State. Welcome to the Dumo Group. Here we focus on materials for device applications. Our focus is more on organic materials, for example, semiconductor polymers, also on hybrid material like metal halide perovskite. We also work on quantum dot for optoelectronic and photovoltaic devices. Our focus is more on the degradation mechanism and the stability of the devices for application in outdoor or indoor environment. We also push more low-cost fabrication, especially in the metal halide perovskite, where we make them in ambient for research accessibility and any other things that we can think about. Yeah.
Hi, I'm Jensen.
And I'm Mikita.
We both work in Dr. Rob Hickey's group, and we do a lot of polymer synthesis and polymer physics. So we have a couple projects in hydrogel materials, pre-ceramic polymers, and hybrid polymer ceramic type polymer grafted nanoparticle materials. So we're going to take you on a little tour of our lab space. So here we're in floor 318 of the Steidle building. It's a community lab space that are shared between a couple of research groups. The Hickey group is kind of right here in this front corner. This entire aisle, as well as that aisle, completely dedicated to fume hoods and benchtop spaces, where we can do kind of wet chemistry and material synthesis and sample prep inside the fume hoods, as well as lots of storage space for our glassware, our supplies, our chemicals, and any samples we create. So we have kind of this whole deep space. Right on these sides, we have kind of the standard sized fume hoods that are basically have the storage cabinets underneath. And as we come down to the next bank of fume hoods, we also have a couple like full-size walk-in fume hoods that reach basically the full height of the human. So in this one specifically, we have a couple pieces set up. On this side, we have just a vacuum drying line for, in this case, a polymer sample being dried so that it can be used for characterization.
And here we have our flask under vacuum that we got rid of all the oxygen for the anhydrous reactions that we wanted to do. And here we're depositing some tetrahydrofuran in it.
Hi everyone, my name is Urara Hasegawa, Assistant Professor of Material Science and Engineering. And my group is developing polymeric material for biomedical applications. And my group synthesizes polymer and develop nanomaterial, evaluate them in biological systems.
Hi, I'm Mary Kate.
Hi, I'm Jacob.
And we're both part of Dr. Susan Sinnott group here at Penn State. As a computational group, we focus on using and developing atomistic scale models and methods to design and investigate materials and their properties.
And more specifically, Mary Kate and I are a part of the Penn State MRSEC. So this is across different colleges here at Penn State and other universities where we explore high-entropy oxide systems using these tools.
What we have here is the computationalists will have meetings, we'll discuss research, collaborations, we'll do our own studying, we'll do homework. Really it's just a space to come together and have open discussions about the work that we're doing. As computational students, we're always looking for whiteboards, and luckily in this room, all the walls are whiteboards that we're readily able to use and write on.
Hello, and welcome to the Sinha Research Group, where we explore the utility of bio-inspired sequence-defined polymers. And we make these out of various combinations of peptides, peptoids, nucleic acids, and their conjugates to assemble the next generation of biomaterials and nanocomposites. Using high-throughput synthesis and characterization techniques, we screen to identify unique sequence-driven and molecular-driven structure property relationships that can alleviate material design limitations in healthcare, energy, and sustainability fields.
Hi, I'm Shaylee, and I'm a graduate student at Penn State.
Hey, I'm Jess, and I'm also a graduate student at Penn State.
And we're part of the Morrow Group. The Morrow Glass Group works on a very diverse set of research, all related to glass, but we also work on glass coatings, on glass ceramics, computations and simulations of glass.
We also work on fundamental structure property relationships of glass, working on making glass more sustainable for a more environmentally friendly future. And we work on things that are very specific applications like glass bottles or bioactive glasses.
Let me turn this over now to Dr. Fecco, who will be giving the virtual lab tours for the Millennium Science Complex. Dave.
Thank you, Professor Morrow. It's a pleasure to meet everybody. I'm going to share with you a little bit about one of the complementary organizations to the Material Science and Engineering Department, which is the Materials Research Institute on campus. So first of all, let me just kind of give a high-level overview of the institutes at Penn State. The institutes are organizations that cut across vertically across the horizontal, across horizontally across the verticals that are made up by the individual academic departments on campus. So on campus, we have about 25-ish or so departments that do research on materials. And the Materials Research Institute touches all of those different organizations. You've heard a lot in the last, half hour or so from some of the different faculty groups that are in part of the Material Science and Engineering Department. And a lot of the capabilities that exist in Steidle building are very, they're excellent capabilities, but sometimes we have a need for shared facilities that all of the different departments that do research and materials have a need for example, things like high resolution electron microscopy. And that's where the institutes step in. So the institutes you can think of as the research, the home for a lot of the research that gets shared across the different academic departments. So here's a image of the outside of the Millennium Science Complex, and Materials Research Institute is one of the two institutes that have a home there. Just overhead map here. Here's Steidle building, and here is the Millennium Science Complex. You can see it's about a 13-minute walk. So it's close enough that you don't need to get into a car or on a bus to ride over. You can just walk across campus and get here to use the facilities. The Millennium Science Complex was completed in the fall of 2011 at a cost of $230 million. That doesn't include any of the research equipment that's in the building. That's just the building itself. So it's a very expensive building. A lot of the costs went into the functionality that's built into this building for things like, for example, the clean room that's on the first floor and the lab spaces that house our analytical equipment. Inside the MSC, we have both the Materials Research Institute and the Huck Life Sciences Research Institute. There are two wings to the building, which you'll see in some of the pictures here that I show in a second. There's about 300,000 square feet of open access research space, which really allowed the university to bring together a lot of capabilities that existed in different parts of campus and bring them under one roof. The shared facilities that are in the Millennium Science Complex are for materials are our nanofabrication laboratory, which is expanding. That's about 10,000 square feet of clean room space with about 5,000 square feet of chase space. We'll be adding about 2,000 square feet to that space, primarily for electronics packaging. So if that's an area that's of interest to you, know that we're adding capabilities there. We also have the materials characterization lab that lives under the garden area, and I'll show you that in one of the videos here coming up. And then we have a user facility for two-dimensional growth that's called the Two-Dimensional Crystal Consortium. We're focused on growth of transition metal dichalcogenides there. One of the keys to the institutes and the success of the institutes is the staff. So we have about 50 experts on staff here that help to run the equipment. And that's also something that you typically won't find, at least at that level, in the individual departments. So all of the departments will have the graduate students and the faculty, but at the institutes, we have folks that are there primarily to keep the instrumentation running, but also to help train students to safely and efficiently use the equipment and get proper results out of the equipment. And that's very important. Sometimes if you need access to a piece of equipment that's in another faculty lab, there are a couple of hurdles that you have to figure out. One is, how you can essentially how you can reimburse that other faculty group for using the equipment, and then also, who's going to train you on that equipment. Whereas in the institutes and at the facilities that I've mentioned here for MRI, the staff are there. The equipment is accessed by a shared user agreement where the different research projects that you're working on will actually pay for the instrumentation. So there's a transfer of funds there to help to support that. But then the staff are also there. It's not as if you have to wait for someone to have an opening in their schedule to train you. That's what these folks are there for. They don't have their own research projects that they're running. Their research, their job is to keep that research equipment up and running. So let me just a couple of images of the Millennium Science Complex. This is a nice kind of image at night. You get a sense for the building. It really does look kind of like a spaceship. There is an overhang at the front of the building that covers the garden area. And then this wing down here is the Materials Research Institute wing, and this wing is the Huck Life Sciences wing. And here's another picture of the building in daylight. You get a better view of the garden area itself. You can see there are 3 floors above ground, and then we have the research space that's in the basement where the analytical labs live. Walk us down through one of the labs here so you can so this is the outside of the Millennium Science Complex. There's a little bit of bird noise that you can hear, but you can see we're going to go in through the lobby and down through the elevators. And down the corridor. And into the lab. So I'll, as I said, I'll send these links so that you can actually go in and kind of walk around the facilities for yourself. But this is what it looks like inside one of our labs. This is the X-ray diffraction lab. There's a couple of things to point out here. One is that we do tend to buy a lot of equipment from the same vendors. So, for example, a lot of our X-ray diffraction equipment comes from Malvern Panalytical. So there's a little bit of ease of use to make the different interfaces between the different pieces of equipment the same. It's of great value to the institute because we get more buying power by buying from the same company, but we also, for service on the equipments, to keep the equipment up to operating properly, we have somebody that can come in and service all of the equipment at once. But we do, as I mentioned before, of the 50 staff members, I think we've got about 4 or 5 of them that really have their primary responsibility in X-ray diffraction. It's a big part of what we do. So let me back out of this, and I'll pop into the nanofab through the same route. We're going to go in through the lobby. This time we're going to go to the right, down the hallway, and into the nanofab. And as you walk into the nanofab, the first thing you'll notice is the fact that we have the lights in the nanofab are They appear kind of orange. That's because the light lacks the UV component that is required for curing of the photoresist. But we can go into the nanofab itself. You can see a lot of the different equipment that's in the nanofab. We do all manner of depositions, lithography, and etching. And as I mentioned, we are expanding out the packaging area of the nanofab. So you'll see that coming in the near future. And we've got one more tour for you. This is our scanning electron microscopy lab that's in the Millennium Science Complex. These instruments are similar to the instruments that are in Steidle building, but you know, again, the staff are there to train, and I think it's fair to say these instruments have a bit more capabilities than the ones in Steidle building. Take a look at your convenience and stop by, but that's what I have for you on tours of the Millennium Science Complex.
Great. Thanks so much, Dave. Okay, next up is Jensen with a presentation about life in State College.
And I'm going to be talking a little bit about life in State College and why I think it's great to live here and you should consider coming here outside of some of the things that the department has to offer. But first, we will start within the department. So as far as like social events and kind of community development within our organizations, we have a lot of departmental events at MatSE. Two specific ones are the Millennium and Steidle cafes. And so that's just listed here. So kind of as we've seen from our tours, the top picture here is showing us the Millennium Science Complex, and the lower one is our Steidle building. Both of these offer kind of these cafe events that are consist to either talk about research that's going on throughout the department or engage in kind of social events that are happening. Some other things include our like annual MatSE picnic that really kicks off the year. Our MatSE Appreciation Day, which you can see in this photo here with some of the Morrow Group members. And there's also often ice cream socials featuring ice cream from our on-campus Berkey Creamery. We also often do a chili soup cook-off and a variety of other things, as well as individual research groups often also host their own events. And then kind of going above the department in a broader sense, the College of Earth and Mineral Science, as well as the grad school, also often host certain events. One of those are a night at the museum. In the College of Earth and Mineral Science, they do have their own museum, and they often have like kind of social events in which you can tour all of the exhibits kind of after hours. There's also a welcome month in the start of the fall semester to get new students kind of acquainted with a lot of the resources that are available to us. And one of the events that I really enjoy and wanted to highlight is hosted by a student organization called the GPSA, or the Graduate and Professional Student Association. Each year they host an annual winter gala, which is kind of a chance for grad students to kind of dress up in their finery and feel fancy and exciting for a moment. So here's a large group photo of some of the MatSE members that were there a couple of years ago, as well as my unabashed photo of myself with my partner after we won Best Dressed that I got a lot of the MatSE friends to vote for me on. So thank you to MatSE friends. Also throughout campus, there are lots of student clubs and organizations of all sorts of types. According to like the Student Penn State Club website, there's nearly 1,000 student organizations. 80 of them are specifically targeted to grad students. However, that doesn't mean the other 900 are exclusive to undergrads. You can join pretty much any of them, no matter what status you are as a student. And a lot of these organizations really are focused around a wide variety of topics, such as kind of academic groups or social groups that are focused on music or sports, as well as groups from different nationalities and spiritualities. And if you're interested in philanthropy or politics, there's a lot of groups kind of focused on those as well. And this is all of these are listed on one centralized website on through Penn State's website. Okay, my thing froze, maybe. We'll click here. So I wanted to just kind of give a visual representation next of what's kind of around campus. So highlighted in the stars here is Steidle Building and the Millennium Science Complex, which we've been talking about as our two kind of main houses for the MatSE department. And if you kind of go northeast from there on campus, there's kind of circle here is kind of the athletic area where a lot of the stadiums and arenas are. So you can support the Nittany Lions and hang out with friends at tailgates or games. Additionally, there's a wide area dedicated to campus recreation. So that includes like organized events such as like intramural sports or fitness classes that you can sign up for. There's also a lot of just kind of open rec in which you can use free gym space or select your friends to go play volleyball at the gym. So there's a lot of options there. Our campus building also has a small bouldering wall. Climbing is really popular in this area, which we'll talk about a little bit later as well. But if you're interested more in the arts, that's also kind of all over campus. First, I guess, sort of artsy. There's this art, we have an arboretum that is a great greenery space to kind of chill and relax in. They also have a kind of children's center that has a lot of fun. That's also a lot of fun for adults as well. And they have a natural habitat for like area for pollinators. So it's a great place to check out and hang out. It's also the home of the new Palmer Art Museum. And also across some other areas is the arts district, we'll call it. So there's the Center of Performing Arts within the College of Performance Arts that hosts a lot of student performances that are completely free, as well as they bring in outside professionals for a lot of different events that are often free, sometimes may have a small price ticket. Otherwise, there is also the Center for Arts and Crafts. One photo from them is shown here at the bottom. They host a lot of student classes that you can do things like paintings or stained glass window making, or there's some pottery classes. So that's a lot of fun ways to get involved in the arts on campus. So we talked about a lot about what's on campus and what Penn State has to offer. I also wanted to go off campus and talk about what's happening in the broader State College area and throughout kind of the center region. So what you'll see here, we have in the center, we have a great view of Mount Nittany, which you can also see from Millennium Science Building. And I wanted to just kind of start highlighting a couple of features around town that I really like in different organizations. One is the Shiloh Region Public Library. I am a huge supporter of public libraries. No matter where you end up, you should make sure that you are becoming a member of your library and getting a library card. It's super beneficial to your communities. Next, I wanted to highlight a couple recreational and social groups around campus or around the area. That is the Happy Valley Adventure Bureau, Central Region Parks and Rec, and Climb Nittany. Climb Nittany is a bouldering and top rope climbing gym that a lot of people are members of, and the other two often host a lot of events for organized sports or social outings that you can meet community members that aren't necessarily involved with Penn State. And some kind of one-off annual events are things like the Wings Fest, which takes place at Tussey Mountain, where you can vote for your favorite type of wing. This happens every Thursday throughout the summer, and they have live music, and it's just kind of a great environment. Every summer, there is the Central Pennsylvania Festival of the Arts, or Arts Fest, which is hosted downtown and on campus that brings a lot of people into town and is a great, really like social party kind of vibe. That's a really fun week in town here. And there's also a community center called 3 Dots that hosts a variety of events, one of which is kind of like just a general block party in which they bring in local vendors at the Pew Street shutdown. Of course, this doesn't want to work with me. And as far as some arts in the area, the State College Theater is kind of a staple of downtown. It's a general movie theater that hosts kind of a variety of popular and indie films. It's actually currently the State College movie festival. Yes, movie festival this week. There's also an improv studio in which you can either view performances or take improv classes. And there's an organization called the Rivet, which is kind of a collaborative maker space. So they have a lot of different woodworking or metalworking machinery that you can rent and borrow to create art on your own. SCYP, or SCYP, is the State College Young Professionals organization that is just a social group to bring together young professionals. And WPSU is an organization on campus that also is essentially a good resource, that they have a listed calendar of events going on both on and off campus. That is a great place to kind of find things to do and learn about what's going on around us. Additionally, we have, we're somewhat in this, even though we're in the kind of central Pennsylvania area away from any major cities, we still have all the basics you might want, like bowling alleys, movie theaters, trampoline parks. There's also a lot of disc golf and mini golf. And actually being in a more kind of rural setting also allows us a lot of access to farms like that allow you for apple and pumpkin picking. And there's also a great outdoor space called Savers Creek, which has a small lake that you can rent paddle boards or paddle boats and kayaks at, that also has a small aviary in which you can see some fun birds that are being rehabilitated here. We also have a wide variety of bars and restaurants and shopping that kind of range from small local businesses to some of the more well-known chain establishments. And a lot of those are all hosted under, there's a great resource run by the State College magazine called The Best of State College, in which you can find any sort of restaurant, stores, services that have been ranked by community members as being the best. So that's a great resource to find new places. And then if that's still not enough for you, around the Happy Valley region, we are located again right in kind of central Pennsylvania. So shown in this wonky shape is the center county. And we're located kind of at the southern edge of it, right here, State College. And just nearby, we have a few small towns that are also have great small, quaint kind of culture and shopping and restaurants that are great to walk around in. If you're more interested in nature and hiking, there's the Rock State Forest just south of us. And also nearby in the area, there's things like the Shavers Creek Nature Center, which I mentioned in the previous slides, as well as Tessie Mountain and Baldy Eagle State Park, where you can kind of enjoy your summer or winter activities. And to help kind of promote some agro-tourism in the area, there is a thing called the Central Pennsylvania Tasting Trail, which is you're into beer or wine tastings. There's a lot of breweries and wineries in the area that you can visit with this tasting trail passport that gets you free samples and free drinks and things like that. And then kind of as a final note is, if you wanted to venture out a little farther, being centrally located in Pennsylvania does mean we are kind of in the middle of a lot of major cities. So to the east, you can visit things like New York, Philadelphia, Baltimore, and DC, or to the west, you can kind of head over to Pittsburgh or Cleveland. And up to the north, we have Niagara Falls and Toronto. Most of these major cities have bus routes to them that you can take, or obviously you can carpool with your friends. And that is everything I had. So thank you so much for your attention.
Great. Thank you so much, Jensen. Thanks to everyone who presented. All right. Thank you, everyone, for joining our event. Thanks to our entire recruitment committee for putting this together. I think everything went really well. So thank you to all of the staff and the faculty and the students for volunteering their time. And thanks most of all to all of our prospective students for coming to learn more about our program. This is the time to put in your application for graduate school. So if you would like to apply, please get your application in, and we look forward to reviewing it. So thank you very much, everyone. Hope you enjoy the rest of your day.